All right, welcome back to Robbie's Office Hours. Today we're talking about expanding sums. Okay, so remember with sigma notation, it's really a compact way of representing summation. Okay, so if I come up here, the way that I actually think about this summation is I start with k is equal to 1, k is my index. I take k equals 1, I plug it in for wherever I see a k. In this case, I'm going to get an a1, and then I just keep adding. So this is my k equals 1 term. When k equals 2, I go up, I get a2. When k equals 3, I'm going to get a3. All the way up to, well, my second to last term is n minus 1, and then my last term is n. So my second to last is an minus 1, and my last term is an. Okay, so again, the moral being, start with k equals 1, plug it in, figure out what that term is, and then add the rest of the terms all the way out. Okay, so we're going to do that for these ones here. So this one here says, look, start with k is equal to 1, plug it in. What am I going to get? I'm going to get 2 times 1 plus 1 over 3 times 1 plus 2. That's my first term. Plus, next term, k is equal to 2. So now I replace the k's with 2. So 2 times 2 plus 1 all over 3 times 2 plus 2. Okay? Okay, that was the k equals 1 term. That was the k equals 2 term. So now I'm at k equals 3. Plug in. So I'm going to get 2 times 3 plus 1 all over 3 times 3 plus 2, and then add the last one, k is equal to 4, and plug that in. So I get 2 times 4 plus 1 all over 3 times 4 plus 2. Okay, so that would be this sum in its expanded form all the way out. Okay, now you could obviously do the arithmetic and figure this out. I mean, what is this? This is 2 plus 1, so that's 3 over 5. So if you want, you could write this as 3 over 5 plus, what am I going to get here? 4 plus 1 is 5 over, what is that, 8? 5/8. 5 over 8 plus, okay, what do I get here? 7 over 9, 11. So I get 7, 11. And 2 times 4 is 8, plus 1 is 9 over, what, 14? So it's 9 over 14. So that would be kind of the simplified version of it, if you will. All right, but that's the expanded form. And we can do the arithmetic, we can simplify this, we can do whatever, but that's not the point. The point is, can you take summations and turn them into the expanded form, okay? So next one, let's see what we do. So this one, k is equal to 0, that's our starting point. Okay, so if I plug in k is equal to 0, 0 times pi over 2 is just 0. So I'm going to get sine of 0 plus, now k is 1. Remember, you start with k is 0, you move up to 1, you move up to 2, you move up to 3. You start with k is 1, you move to 2, to 3, to 4. You start with k is 3, 4, 5, 6, and so on. You just increment up 1 each time. Now if k is 1 and I plug in, I'm going to get sine of pi over 2. Okay. If k is 2, 2 pi over 2 is just pi, so this is just sine of pi. And then the last one was k is equal to 3, so that's 3 pi over 2. So sine 3 pi over 2. So that's the expanded form. Now we can go through and try and figure out what these values are. We know sine of 0 is 0. We know sine of pi is also 0, so those are 0. We know sine of pi halves as the top of the unit circle, so that's 1. So that's a 1 here. And so that takes care of that term. And then sine of 3 pi halves at the bottom of the unit circle, so that's negative 1. So 1 plus minus 1. So this is a very pedantic and kind of redundant way of writing the number 0, if you will. Okay? All right, next one. Let's see what happens. So if I start with k is equal to 3 and I plug in, I get 3 squared. So I'm going to get 3 squared over 3 plus 1 is 4. Plus, now k is 4. I'm going to get 4 squared over 4 plus 1 is 5. Plus, okay, so that was the k is 3, k is 4, now I'm at k is 5. So I'm going to get 5 squared over 5 plus 1 is 6. And then now k is 6, so that's going to be 6 squared over 6 plus 1 is 7. And then we could obviously work this out if we wanted to. 3 squared is 9, so this is 9 divided by 4. Plus 4 squared is 16, so 16 over 5. 5 squared is 25, 25 over 6. And then 6 squared is 36, so 36 over 7. So that would be the expanded form of this sum. Okay, and again, we could do the arithmetic, that's fine. All right, one more for good measure. Okay, so this one is very important when you first start talking about what are called power series and things like that. We'll get to that later, but this is a very important concept where x is going to be a variable, okay? So x is allowed to kind of be anything at this point. X is a variable, and then the k's I see are the -1 to the k, I have a k plus 1, and then I have x raised to the k power. Okay, so it's the same principle. When k is 0, what do I get? Well, I'm going to get -1 to the 0, okay, times 0 plus 1, so that's just times 1, times x to the 0, okay? That's the k equals 0 term. Now k is equal to 1, I'm going to get -1 to the 1, that's this term, 1 plus 1, so that's a 2, and then x to the 1, okay? Plus, now k is 2, -1 squared, times k is 2, then I get 2 plus 1, that's a 3, x squared. Okay, so this was k is 0, k is 1, k is 2. Let's do k is 3, so we've got two more, k is 3 and k is 4. So k is 3, I'm going to get -1 cubed. Let's see, k is 3, 3 plus 1 is 4. That's 4x cubed. And then the last one is -1 to the 4. 4 plus 1 is 5, x to the 4th. Okay? So, what happens when we simplify this? Well, let's see. -1 to the 0 power is 1, times 1 is 1, x to the 0 is 1, so this is just a 1, okay? -1 to the first is negative, so it'll be minus, and then 2 times x. I get that. -1 squared is positive, so this will be plus 3x squared, so 3x squared. -1 cubed is negative, so I'll get a negative again, 4x cubed. And then -1 to the 4th is positive, so I'll get plus positive 5x to the 4th. Okay? So that would be the expanded form of this sigma. Okay, so again, this is taking things that are written in sigma notation and expanding them out to try and see if we can try and understand a little bit better what the sigma is actually telling us. Okay, so you like this video, you like it, you want to subscribe, like the video, comment, all the things, and we'll keep this going.